REFLEX, it's a software for the study of reflecting surfaces using ray tracing and specular reflections. The elements that interact on the field are sources, walls, and reflecting screens. Also, reference geometries can be used that doesn't interact with the reflections, but are certainly handy for understanding what we're doing. The source object counts with the following properties: X and Y coordinates for their location. The coverage angle certainly is another important parameter, defined by an initial and a final angle and the resolution between the rays. The direction is the on-axis orientation of the source. The delta parameter is a key property that defines the density of the rays in between the coverage angle. Now, let's talk about the walls. Walls and screens share the same key properties that defines them, which are an initial point and a final point. With this, we draw a line that defines the location and orientation of the wall or screen. It's important to note that the initial point and the final point are useful for us for further investigations. All these parameters can be defined precisely with numeric controls for managing the direction, orientation, and so on. Sources can be moved by simply dragging them on the field. The rays are always updating themselves on real time according with the location of the moving source. Shortcuts as Alt plus click can be used to place the source on the point we want. With Ctrl plus D, we change the orientation of the source in the direction of the cursor, real time. So the source follows the direction of the cursor in movement. With Shift plus mouse wheel, we can change the coverage of the source. With Ctrl plus the mouse wheel, we can change the density of the rays. With Alt plus the mouse wheel, we change the direction of the on-axis orientation of the source. On this example, we are looking at the rays going to a screen and the first order reflection. The black lines geometries here are the reference element that doesn't take part on the simulation or the ray tracing. On the green color, we can see the walls. Now on the light blue ones, we see the reflecting surfaces, the screens. They both, screens and walls, have the reflections properties. And of course, these purple big points represent the sources. On the main menu called C, we can change the order of the reflections that we want to work. We were looking at the first reflection order, and we can go on to the second, third, and so on. Very powerful. So the order of the reflections that we can see in real time is managed on those controls. Very nice real-time processing. The color of the lines are representative of which are the walls or the screens that are producing the reflections. For instance, on this case, there are a huge number of reflections over the field. So we're going to lower the order of the reflection being shown in the program. There is the option of a monochromatic color, which could be useful for a simpler approach. Also, For the first order reflections, we can draw beautiful polygons that represent the coverage. Of course, for some cases this can be very interesting to see. On this main menu, we can turn on and off only the direct rays from the source to the screens and walls, or only reflections. Of course, we can also turn off all the rays. We have also a button for this on this area, so that we can focus on the geometry before calculating the ray tracing. We can change the thickness of any of the elements lines for them to be more visible or as you wish. See, even the thickness of the rays can be changed to be more visible or not. Even a transparency parameter can be changed for them. The reference geometries can be changed here for adding more lines or clear and so on. The screens can also be modified by means of using the mouse cursor, like here, choosing the initial point and moving around. Please take note that the initial point is marked with a circle, while the final point can also be modified with the cursor. With Ctrl plus dragging, we can move around a complete screen. On this example, we see that the selected screen is on a purple color, right? And then we have the option of precisely change the direction. We can change the direction according to the initial point, which is marked as a more thick point, right? We can change the direction. Also, we can change the length of the screen or the wall too. And we can switch this initial and final point and work on the other side. Very nice and flexible. And even more, we can do a subdivision of any wall or screen, like on the example. New screens can be created on the fly very easily. There is an absolute freedom to create elements on the fly as it's needed by the user. When elements get together enough, they get merged, like on a snap way. They will do this with any end or initial point of any walls, screens, choosing between the end point, the initial point, or the midpoint. This is important, the midpoint sources, and also will snap to the initial or the end point of any of the reference geometry. This also works for the zero datum origin point. This can be controlled at the preference menu on the snap section. Then, as we see here, we can snap to walls, reference geometry, midpoints, screens, sources, and we can turn all of them on and off with the proper control. So, when turning off any of the snap, then you can move any of the elements freely around with a flexible not snap to anything. So, with a lot of sources and rays playing around, this can be certainly useful. For creating new sources, we can go to the proper menu and just make a click on the field. Each source has, of course, their own parameters, and they can be configured independently from each other. As the same, it happens with walls and screens. Well, here on the Preferences menu, we can change the colors of the rays, which for the moment it shows 7 of them. Also, the color of the different elements can be changed. This collection of colors can be also imported by using a file created on the program, or we can of course reset them to the defaults. For starting fresh, we can always go to the Reset button and start with the default project, which is on the same folder as the program, and it can be replaced by the user if the user wants it. Also, we can start with an empty, clean project by clicking on New. Then we start fresh, and we go by creating elements on the field. Now, importantly, we have a DXF implementation on REFLEX. So we are compatible with the DXF Universal Autodesk format, and we can get an import of geometry or export of geometry of all elements or certain elements that we want. So, for as an example, we're going to go to AutoCAD and see this geometry here. It is clearly a side view of an auditorium where we can see clearly the scenario and some reflective surfaces up on the top. We have a balcony and a main area of audiences. Also the typical hall for the musicians and such. So, the important thing here is that for the connection between AutoCAD and REFLEX, we have to work based on layers. Okay? Pay attention, please. The key important parameter of the layers being important to REFLEX is the name of the layer. That makes the magic. Okay? So, for instance, the layer wall, screen, source, reference will be recognized by REFLEX to give them the role that they should have on the program. In general, what REFLEX imports are elements such as lines, circles, and arcs. The last two of them, of course, are separated into segments to be useful on the program. So, for instance, if I want to import this arc into REFLEX as a screen, we should do an explode of the element. And the same goes for any shape that we want to work as a screen. And don't forget the name, screen. That's the name for the layer. Now, about the surrounding geometry that can be drawn on the program, or you can just put them on the layer called wall. The sources are defined as an arc, which means the coverage of the source. The center of these arcs are related with the location of the sound sources. So, REFLEX, when importing geometry from a DXF file, when getting into a layer called source, it will look for arcs as the coverage and the center of these arcs as the location of the sources. So, we will see here a modified project in which we have the elements configured on the proper way for entering REFLEX. So, this modified project is properly configured to get into the program. Like for instance, the layer called wall, it's for the geometry, which is imported in this case as walls. This means reflective surfaces as well, just as screens. So they will participate on the calculus of the ray tracing and such. We have also a layer called screen, which are these ceiling screens for reflections. We have of course a layer called source, in which we have different arcs pointing to the ceiling surfaces for reflections, the screens. This arc, for instance, will define the coverage of the source on this ceiling screen. This other arc will define the same location for the source and pointing to the proper screen. This second one is a different coverage source according to the desired screen of reflections. The idea, of course, is to study and investigate how these reflective areas behave on reflex. We will go to the import DXF, and then we can see clearly how reflex recognizes the elements. The software gives us a warning about that we don't have a reference layer. That's okay, we don't have any auxiliary geometry as a reference. No problem. And then Reflex asks us to decide if we want to use the rest of the DXF file as a reference geometry. Then this is what we got when importing a proper DXF file into Reflex. As you can see, the surrounding limits were imported as walls because they were on the wall layer. Now, the screens, it goes the same. See, they were called screen as their layer on the DXF file, and then they are converted instantaneously into screens on the program. And as you can see, they are subdivided into segments for the geometry of the program to work properly. Sources, they entered as arcs with a center located on the location of the source. And the coverage for each source is defined by the coverage of these arcs. So we can see that 4 sources were created. Then we can turn off or on some of them and continue with our project. The first for the first screen, the second for the corresponding second one, and so on. With these important functions, we can draw a model in AutoCAD and then see in Reflex how these reflective surfaces behave. So now we can go the other way and export a DX file containing all the arrays or presenting them on the architectural file on AutoCAD. So we go File, Export Arrays, I will here change the name. And then we go. So the arrays were exported. So now we go back to AutoCAD and import the DXF file, and we can see the arrays. Of course, we got them as geometries in AutoCAD. If we choose and copy these arrays, and then go to the original file, and go to paste them, and we will see a very nice presentation in AutoCAD of our ray tracing on the reflective surface. So this would be a pretty nice application of Reflex combined with the AutoCAD worldwide standard for presenting reflecting surfaces and the rays coming from the sources into an architectural file. So as a summary, we get to know that Reflex is completely compatible with AutoCAD via the DXF file, in and out. Now we're gonna change the page and talk a little bit about noise control. Reflex has some functions that would be very interesting for this matter. Please pay attention. We have this building inside a residential area with this location with a noise source which is impacting the community around. We have the point number 1, number 2, and number 3. That seems like houses that certainly could be being affected by the noise. Hopefully, we are going to get some insights about what it can be done to avoid this acoustical noise stressing the neighborhoods around. We'll start by obviously exporting this image out of Google Earth, and it's important to export the scale that Google Earth provides for us to get proper scaling into Reflex. Again, just like in other of our softwares, the scale is very important. You can imagine why, right? We need to have a reference of the scale for having a proper modeling in Reflex. Of course, we don't have to mention that Reflex is already able to import any images of reference. And don't forget about the scale, no matter if the images are coming from blueprints, from Google Earth, Google Maps, etc. So we start by saving the image with the proper scale, and we go to Reflex and import the image. Options, background image, and we import the file. As a default, we will see that on Reflex we have a 100% scale, and we will change this. So we go zoom into the Google Earth scale mark, which in this case is 20 meters, right? And we go to the proper controls to change this. So it's simple as putting the 20 meters here, and then we click one point and the other, and boom, you have your properly scaled image on the program. As we can see, the image grown bigger. Now it's completely scaled and ready for work on it. Below, we can see the real-time coordinates of the point that we are moving the cursor on over the image, the scale being applied, and so on. Each time we click a point on the model and then we click another one, the distance between these points is displayed on screen for internal use, for checking if everything is okay with the scale, and that's it. Now, rapidly, we're going to start by drawing some walls. We're going to do this fast. This is just an example, but it would be illustrative about how the program works. We draw these walls, simulating the reflecting surfaces on the field. We are simply surrounding these houses. We have a reference of what is going on here. Let's continue with this. There we have the drawing of the walls on the receptions places, the houses around the noise source. Source clearly has a building next to it, so let's go with this also. Very easy to draw the walls, as you can see, with the properly scaled image. It's just go and draw your walls. Now here we are going to locate the main source of noise, right? And with just a click, we will make this source to be omnidirectional. This means radiating sound everywhere. And here we can see a first draft of the general situation around the source. The points number 2 and 3 are the more affected, as if we see the number 1 point of interest, it's somewhat protected by the building on the side of the sound radiation source, right? So we could start by creating a screen that goes from here to here and here, so that we are kind of surrounding the noise source. Then we see that the point number 3 is covered, but the number 2 one has some second order reflections that are getting into it because of the walls of the building next to the sound source. So it's not enough with that screen, and we project a little bit larger screen to protect the neighborhoods from the sound, and we see clearly how it gets better. The situation gets a lot better. Less sound radiating into the neighborhood with more projected screens to protect. This is REFLEX by Agata Research. We are so proud of the software, and we want to continue with the development of this. We think that it's important to get into the game of ray tracing and reflecting surfaces and so on. This is a real example. This is the geometry which is existent on the place. Okay, this is Santiago of Chile. We can see that some protections were created, but still we can see that some of the noise is propagated outside of where we would want to be protected. By the way, we are looking at 50 reflections. REFLEX has a power horse that allows us to get into any order or reflections. It's a work of art, really. It's crafted by mastermind Hector Montoya, senior acoustician and programmer at Agata Research, and we are so happy of this work. This is for sound control, sound propagation, noise pollution, and much more. Educational stuff and more and more. REFLEX. Back on the project, we can see that the worst area of sound propagation and noise is around here on the number 1 point of interest. We can see also that number 3 and number 4 points of analysis are also kind of affected by reflections and sound being propagated to the places. We could, of course, simply closing places with screens, but we are looking at an existing situation and it is what it is. This is what is happening with the reflections and the sound being propagated to places that we don't want. So, REFLEX allows us to study and understand the damage that noise sound sources are creating into the neighborhoods around places that produces this sound. Getting back to the defaults on the program, we just press reset and start fresh. So we are presenting REFLEX, a software that we think it has a place for us to understand sound pollution, noise control, and reflecting surfaces. This is an effort that it has a wonderful story we're going to be telling you about, guys. This is a software that it's 20 years old on the mind of Hector. This was the thesis project for his degree on acoustics engineering on the Austral University of Chile, the mother of acoustics in Chile. And we are so proud. We invite you guys to try to test this, to play with it, and get into the game of ray tracing for all of you guys. We love you guys. Thank you so much for your attention. Agata Research, we go for it. Thank you so much.